Hey, gentlemen. How are y'all this morning?
Good.
And Grayson, that's really cool that your family's going to go help in Alabama. That's really sweet. I'm going to try and email you, and I guess I'll email Courtney too then with the worksheets that we'll do on Friday.
But I don't know. I won't know how to do them because I won't be in class. So
yeah, well, you can watch. That you can watch the Ed puzzle. And it's really undoing the difference of squares. I mean, what we're going to cover is the Ed puzzle that you're going to have today.
I already watched the Ed puzzle and it's kind of confusing. Part of it might make sense, but I'm not really sure.
Okay, well, it is undoing the difference of squares. That whole thing, remember last Wednesday that we did, and we did the difference of squares, and it was the, but anyway, if not, we can go over it on Monday, but if that's the work that we're doing, and when you emailed me, that's what you asked for. So that is what we'll be doing. So it'll be a worksheet on that. And I will send like the answer key to the notes. So maybe between the Ed puzzle and the notes, maybe that'll help. You can always just try.
Well, a couple questions.
Yes, sir.
Could you post the Ed puzzle today so I can try and get my work done today so I don't have to do it like.
You mean the weekend Ed puzzle?
Yeah.
I can try. I just can't make any promises about that. Because of my niece being in the hospital in ICU, I'm kind of behind on grading too. So all that grace that I extend you guys, I need a little grace from you guys.
Okay.
So, but I will definitely try to get that done. But obviously, since you missed on Friday, it's not you're going to be missing on Friday. It's not. I will extend you that same grace. You know what I mean?
Yeah, because I don't think I'm going to be able to do the worksheets. I can barely do this worksheet.
Oh, that makes me sad. Well, hopefully we'll hit enough of them today, that it'll start, clicking and making sense, and you'll be able to knock them out. Okay?
Okay. Could you maybe just help me with get me on the right track on the weekend homework on Monday?
Oh, absolutely, honey. Oh, yeah.
Okay.
Yeah. All right.
Thank you.
Yeah, what I'll probably do is just go ahead and teach whatever I was going to teach on Monday, and then after we get done and everybody's working on their work, I'll work on both worksheets with you.
Okay, thanks.
Okay. No problem. All right. Let's get started on this worksheet, factoring out the greatest common factor. So basically what you want to do is you want to look at the terms within the polynomial in the first one that's a binomial, and you want to look at it and you want to see is there a number that goes into both of them, and is there a letter that's contained or a variable that's contained in both terms. In that first one, can you all think of a number that goes evenly into 7 and 49?
Seven.
Good job. 7. So if I factor out a 7, what would be left from 7x? If I have 7x and I factor out a 7, what is left?
The x.
Yes. All right. And if I factor out a 7 out,
Be 7.
$49 divided by 7 is what?
7.
7. Good job. So that one's factored. All right. We look now, number 2, we look at 8m minus 6. What goes into both of those evenly? What number?
2.
2.
2. Good job. So if I factor out a 2 from 8m, what would be left?
4m maybe?
4m. And if I factor out a 2 out of 6, what would be left?
-3.
Yep. So that one's done. So what goes into 5a squared and -15 evenly?
Could you repeat the question? Sorry.
What goes into 5a squared and 15 evenly?
5.
Okay, so if I factor out a 5 out of 5a squared, what's left?
I don't. Just a squared?
Yes. If I factor out a 5 out of 15, what's left?
-3.
Okay, so for number 4, what goes in to 12 and 20 evenly? The biggest thing that you
4.
can think of. Yes, 4. Good job. 4 goes into both evenly. Is there a letter that is contained in both of them?
No.
The same letter. Okay, so we can't factor out a variable. How many times does 4 go into 12c squared?
3.
Mm-hmm. And what so that the 3 is left, and what else is left for that first term?
C squared.
Yep. How many times does 4 go into 20d squared?
-5d squared.
-5d squared. So that one's done. What number goes into both 64 and -40? The biggest thing that you can think of.
I know 2, but I'm pretty sure there's something bigger, but I can't think of it.
Yes,
4?
2 definitely goes in. 4 definitely goes in.
8?
Yes.
It's 8. It's 8.
8. Good job. 8 goes into both. Good job. Okay. If I factor out an 8 out of 64, basically I'm dividing. 64 divided by 8 gives me what?
8.
Yes. Factoring out is the same thing as dividing. Okay. You're dividing out.
No.
You're factoring it out. The difference is that you're putting it, the difference between actually dividing and factoring is that in factoring, you're leaving it in its multiplied or product format. So 8 goes into -40ab. What would be left?
-5ab.
Yep, that's it. All right, on number 6, I'm going to give you guys a hint. Most people don't know their 12 multiplication facts really, really well. So I'm going to give you a hint and let you know that the factor that you can factor out of that one is 12. How many times does 12 go into 36?
3.
3 times.
Yes. The other thing I'm going to ask is there a letter, a common letter in both of them?
Yeah, A.
Yes. Hey, Roger. So if there's a common letter, you take the one with the smallest exponent, which is going to be the exponent of 1, because this is an understood 1 right there. So how many times will 12a go into 36a squared? Y'all already told me this part was 3, but what would be left? A squared.
3a.
Yes, good job. There would be an
That's
A
2.
left. Plus 2. Good job. Y'all are doing great. All right. So number 7. What number goes into both 18 and 12? And also, is there a common letter? And if there's a common letter, which one has the highest the lowest exponent?
It'd be 3, I think.
3 definitely goes into both of them. But let's look at if we do 3.
Wait, 6, right?
Yep, 6. All right. And then what's my letter going to be?
X.
Yes. And what is the one? Would it be just an X by itself?
I think so.
You pick the one with the lowest exponent. Which one of those two has the lowest exponent?
I can't talk. X squared.
Okay. So if I did just an X, wouldn't there be an X left?
Yeah.
So you want to do the X squared. Does that make sense?
So every time it's the one with the smallest exponent, right?
Correct. It's the one with the smallest exponent. Does that make sense to you, Eli and Roger?
Yes.
Okay, good. Okay, so if I take a 6x squared out of 18x to the fourth, what would be left?
3x squared.
Good job. Just showing y'all what that would look like. So, and then 4 minus 2 is 3x squared. So that's what it looks like. Okay, now if I take a 12x squared out of a 6x squared, what do I have left? Those would cancel. Twelve divided by 6 is anyone? 12 divided by 6?
2.
2. Okay. Number 8. What biggest number goes into both 12 and 20?
Sorry, I accidentally clicked something and left the call.
Oh, okay. That's okay. When I'm over on the worksheet, I can't tell who's in and out. But okay,
Yeah,
we're on
it's
number 8.
4.
Yes, it is 4. All right. Is there a variable that is contained in both terms?
B.
B is contained in both terms. Which one has the smallest exponent?
Just B with an assumed 1.
Good job. Good wording too. Way to go, Grayson. All right. So how many times will 4b go into 12ab cubed? What would be left? If I took a 4b out of that 12ab cubed, what would be left?
3ab squared.
Wow, that's amazing. Yes, that is it exactly. Does everybody understand where Grayson got that?
And then it'd be plus 5.
Good job. Please stop us if there's any place that you don't understand, and please feel free to volunteer also. I appreciate your help, though, Grayson. Is it making more sense now?
Yeah, I think the best way I learn in like all situations is by doing it. If someone shows me, tells me anything like that, I just have to do it in order for me to feel confident that I know how to do it. Like after I do it a few times, then I know I can do it.
Oh, absolutely. That's pretty typical. I understand that
That's
completely.
why with like the worksheet of 24 problems, after I do several, it makes more sense.
Yeah, it clicks.
Yeah.
I know. I'm the same way. Whenever I learn something new, I have to do it a few times.
I really enjoy math lab because it helps a lot.
Oh, that's awesome. That's awesome. I love that. I appreciate that you come and you participate. I love that it's used. All right. So for number 9, what will go into both 10 and 5?
5.
Good job. All right. And is there a variable that's in
X.
both terms? Yes. X. And so if I took a 5x out of a 10x squared, what would be left?
2x.
Correct. 2x. And if I took a 5x out of a 5x, what would I have left?
Plus 1.
Yes, a 1. Because that's why it's 1 is if you look at it this way, anytime you have something over itself, so 5x over 5x, that's the equivalent of 1. If I have 10 over 10, it's 1. If I have 100 over 100, it's 1. 4 over 4, it's 1. 4AB over 4AB is 1. And you really can't forget to write that plus 1. That's really, really important. Okay. Number 10. What goes into both 14x and 21x squared? We have matching variables too. I'm sorry. I think I spoke over somebody. I think somebody gave an answer, but I didn't hear it.
No, I think I spoke over you. But I said 7x.
7x. Good job. Okay, so 7x goes into 14x. What would be left?
2.
2. And then 21x squared divided by 7x. So what if I took a 7x out of that, what would be left?
3x squared.
Just not 3x squared.
Oh, I'm sorry. I wrote down 3x on my paper, but then I said 3x squared.
Totally get it. Happens to me all the time in math lab. All right. Number 11. What will go into both 81 and 48? I think I might have done this one on the board yesterday because I did the birthday cake method.
I don't know.
Do you all know about the divisibility rules? You know, if it's even, you know that 2 will go into it. Does anybody know the divisibility rule for 3? Anyone know that or heard of it?
Hold on. A number is divisible by 3 if the sum of the digits is divisible by 3.
Good job. So if I add 8 and 1, what do I get?
9.
Is 9 divisible by 3?
Yes, ma'am.
Good job. If I add 4 and 8, what do I get?
12.
Is 12 divisible by 3?
Yeah.
All right, so let's try 3. So 3 goes into 81. Oh, wait, let's pick out. Is there a matching variable in both terms also? Let's go ahead and fix that too. Is there a variable in both terms that matches?
Yeah, 3m.
Okay, so we're going to do 3m. Just like Post-it notes, right? Okay, so 3 goes into 81.
27.
Good job. 27 times. And the m's would cancel. And 3 goes into 48. I know that one. 16. And the m's would cancel, but I still have this n. So the n would be there. So basically what we're doing in factoring, you're pulling out something that matches and writing it, or that is in both terms, and writing it in its product format. Product format means this, if I were to distribute them back out by multiplying or distributing, I should get the answer that I started with. That's what factoring is, taking out something that's common. All right, number 12. What goes into both 8AB and 56A? What number goes into 8 and 56? And is there a matching variable?
It's 8 and A.
Yes, 8 and A. So if I took an 8A out of 8AB, what would I have left?
B.
Good job. And if I took an 8A out of 56A, what would I have left?
-7.
Yes. So there's my answer. Okay. Number 13. I don't have any coefficients on this one, so I'm only dealing with variables. What variable matches in both of them? There's a variable in both of them. What is it?
A.
It is A. And I have to take the one with the smallest exponent. Which one is that?
Just A.
Just A. Good job. So if I took an A out of A squared B squared, what would be left?
AB squared.
A B squared. And if I took an A out of an A, that would just be A over A. So what would that be?
Cancel.
It cancels, but what does this equal?
1.
Yes. Don't forget that one, guys. That's really, really important.
Oh, yeah. I got messed up because it was just a variable.
Yep. And so don't forget that. That's really, really, really important. Eli and Roger, does that make sense to you guys? Just kind of checking in. Please stop us if there's something you don't understand. You want us to do it over. I'm sorry, I spoke over you, Roger. Are you good on that?
That makes sense.
Yes, ma'am, that makes sense.
Okay, good. Bye, Momo. Love you. Have a good day. Okay, so number 14. Is there a variable common in all three? It has to be. Yes, good job. It has to be in all three. And
I was going to say XY, but.
Yeah, but it's not in all three, is it? So,
no.
Yeah, good job. Good catch. All right. So if I took an X, I have to take the one with the smallest exponent. So that's an X to the first power. So if I took that out of the first term here, what would I have left?
X squared Y squared.
Good job. X squared Y squared. Because basically what we're doing is using those good old exponent rules. So you're subtracting. Basically, it looks like this. Remember the exponent rules, we would have subtracted 3 minus 1 to get X squared, Y squared. That's what's playing a part right here. Okay, so this second term, if I took an X out of that, what would be left?
XY.
XY. All right, don't get tripped up. What would be our final term?
Plus uno.
Good job, plus 1. Because you can't forget that, because remember that final term is X over X. And that is the equivalent of 1. Don't forget that. That's really, really, really important. That happens actually a lot as you progress through math, that plus 1. So or sometimes obviously it's a minus 1 if the preceding sign is a negative. Okay, so that's really, really important. Don't get tripped up by that. Okay, so now we're looking at number 15. So number 15, we have a 15 and a 30. What number goes into both 15 and 30? And do we have any matching variables?
15 and XY.
Yes, 15, and then there's an X in both of them, and there's a Y in both terms. So 15 XY, and we picked the term or the variable with the smallest exponent, that assumed 1. So 15xy divided by 15xy leaves me with what?
They cancel.
They cancel, but what do I have?
Oh, 1, right?
1. Yes, don't forget
I forgot
that.
that 1 again.
Yeah, that's happened on every single one of these, hasn't it?
Yeah.
On number 13, 14, and 15. Somewhere in the problem, we have that 1. So that's really, really important. Do not forget that when you're doing this, that you've got that 1, okay? Make a note to yourself. Okay, so if I have a 15xy and I take it out of 30x squared y squared, what would I have left?
2xy.
2xy, because 30 divided by 15 is 2. X squared divided by x is x. Y squared divided by y is y. Okay, number 16. Once again, just giving you a big hint, because these are those those multiplication facts that not everybody focuses on, those upper ones past 10. Nobody likes their 11s and 12s. So with that big hint, can anybody tell me what goes into 36 and 48?
12. I wrote down 6 until you mentioned that.
Okay, well, 6 definitely would. Let me show you guys something.
12.
If I took 6 out, I would end with 6 AB squared. I'm just going to show you guys this part real quick. And I would have 8A squared B like that, right? And then you could look at that and go, ooh, I can take a 2 out of that also, right? So you would take that 2 and you would multiply it by that 6 to make it 12. Does that make sense? You know, just like when reducing fractions, you can keep taking it down. So if you don't notice something right away, and then you see that it can be reduced further, keep reducing it. Does that make sense to you guys? Or did I lose you?
No, your reducing makes sense.
Okay,
That
good.
makes sense.
Okay, good. All right. So if you accidentally don't like recognize, because this this will happen to you. I mean, I know it's happened to me with factoring over the years. I'm like, I automatically think it happens to me for whatever reason. A lot of times when it's 4, and then I realize, oh, I could get 8 out of it. Kind of like the one way back up here on number 5. I would think, 4, but actually when it's a 64, I know that that's a square of 8, but just know that you can reduce it even further. And that's how you would do it. All right, so let's go back from scratch and kind of cover our variables. I'm going to take a 12 out. And what matching variable do we have? Do we have 1 or 2 in this one? And number 16, what variable is in both of them? What variable or variables is in both?
AB, right?
Yep, there's an A, B in both of them. And you take the one with the smallest exponent. And the one with the smallest exponent for each one is A, B. So if I take a 12AB out of 36AB squared, what would I have left?
3B.
Good job. And if I took a 12AB out of 48A squared B, what would I have left?
Negative 4A.
Good job. All right, number 17. What goes into both 30 and 35?
5.
Good job. So that would, and then what are the variables that are in both of them?
X squared and Y.
Good job. And why did you pick x squared, Grayson?
Because it's the smallest.
It's the
Or the
variable.
variable, yeah.
It's the variable with the smallest exponent. Like, so if I'm looking at just the x's, there's an x cubed and there's an x squared, and x squared is smaller than x cubed. So which one would I pick for the y? What did you say?
Just plain old Y.
Just plain old y. All right, so if I took a 5x squared y out of 30x cubed y, what would I have left?
6X.
6x. Good job. And if I took a 5x squared y out of a 35x squared y cubed, what would I have left?
7Y.
7y. And then what else? It's cubed on this one. Y cubed.
Oh, yeah, Y squared.
Yes, good job.
I didn't catch that.
Yeah. Oh, that's okay. It happens. Look how I wrote that. That's scary.
Mine's even scarier.
Okay, so now looking at number 18, what goes into both 9 and negative 30?
Oh, it's 3.
3. And are there matching variables in all of the terms? Like, is there a variable that's in every term?
R and S squared.
R, good job. Picking the one with the smallest exponent. S squared, good job. Okay, so if I took a 3rs squared out of 9r cubed s squared, what would I have left?
Oh, 3R squared.
3. Double check your r. Oh, you said r squared. I'm sorry. I'm
Yes,
thinking
ma'am.
s. Sorry about that.
You're fine.
Okay, so if I took a 3rs squared out of 30rs cubed, what would I have left?
Oh, 10S. Negative 10S.
Good job. That is a 10, I promise. All right, good job. All right, number 19. 75 and 60. This is one where you would probably, if you didn't know right off the bat, my tennis players are probably going to know, just because scoring in tennis goes up by 15s until you get to 75, and then they use something else. If I'm not mistaken. What is it, 15, 30? Now I can't remember. But 15 goes into 75 and 60. But if you didn't know that right off the bat, this is why Miss Sparks loves that birthday cake method. Looky there. There it is. But you would want to factor all the way out. And there's your 15 right there. So 15, when you get a common factor like that, you can take 15 out of both of them. So 15, and then what would your variables be? What variables match in both of them?
Oh, X and Y cubed.
Oh, good job. X.
But
and
literally,
Y.
I have 3 pencils, and now all 3 of them are not working.
Oh, wow. Bless your heart. Kind of sounds like the story of my life. Okay, so 75 or 15 goes into 75 5 times. And then x squared, what would be left out of the x's on the first term? Anybody? Grayson's probably getting a pencil, so if somebody else can volunteer.
Yeah, I'm trying to fix it. I'll let someone else take a shot at it.
Okay, so look at it. If you've got 75x squared y cubed, and I've got 15x y cubed, we've already determined that this is 5. I've got x squared divided by x, so what would be left? Think about your exponent rules. 2 minus 1 is what?
xy to the second.
Oh, good job. X. Well, actually, you got this is a cubed right there. I don't know if you can read my writing. Sorry. So it's just going to be y. But good job, Roger, for it is x. And then actually the y won't be there at all. Because that would be y cubed divided by y cubed, which equals 1. And then 1 times 5x is 5x. But the x was on point. Good job. And then over here, we've got 60. And 15 goes into 60 4 times. But look at this. This xy cubed matches the xy cubed. So you're only going to have the 4. Does that make sense?
Yes.
Okay, cool. Good job. All right. So now number 20, we've got 3 terms. So we're looking at what goes into 5. Let's just deal with the coefficients first. 5, 10, and 25. What number goes into all 3 of those?
Is it a problem if I do like the last section of this in pen? Because I can't get any pencil to work.
No, that's not a problem, honey.
Okay.
Just don't make any mistakes.
And I'm not even at my house right now. I'm at church because my mom works at church, so I just have to stay here and do my homework.
Mm. Oh, bless your heart. You really can't find a pencil then. That's hard.
I mean, I could have run to the church and find one, but
yeah, then you'd miss math lab.
yeah, exactly.
All right. Well, we're looking at number 20, and we're looking to see what number goes. We're just dealing with the coefficients. We have 3 terms. What number goes into 5, 10, and 25?
5.
Good job. 5. Okay. Is there a variable that is contained in all 3 terms?
A.
Yes, good job. A. Okay. So if we took a 5a out of 5a squared b squared, what would be left?
Just 5
There would be
b square.
There wouldn't be a 5 because 5 divided by 5 is,
sorry.
so you would have a b squared and 5a into 10ab. What would we have left?
Plus 2b.
2b plus, and then what would be our last term?
5.
Good job. All right, number 21. What number goes into 10, 2, and 14?
2.
2. Okay. So, is there a letter or a variable that's in all 3 terms?
X and Y.
X and Y. And that's the one with the smallest exponent of each one? Yes. All right. So if I take a 2xy out of 10x cubed y squared, what would I have left?
5x squared y.
5x squared y. And if I took a 2xy out of 2xy squared, what would I have left?
Negative y.
Yep, only the y, because y squared over y, that's 2 minus 1. Remember, when you're taking something out, you're dividing. So you would be using the exponent rule for the quotient rule, which means you're going to subtract the exponents. Okay, so if I have a 14xy and I divide it by 2xy, what am I going to have left?
7.
7. All right, I'm going to do one more, and I'm going to leave the last two for you guys to do on your own. And I think I'm going to pick number 24. So 16 will go into all three coefficients. And what would the letter be?
X squared y squared. No, x squared y.
X squared y. Good job. So if I took a 16x squared y out of 16x to the 6th y, what would I have left?
X4.
X to the 4th. Once again, using those exponent rules, that quotient rule, 6 minus 2, the 6 minus 2 would give me 4. And the 16 divided by 16 is 1, and y divided by y is 1. So moving along. And then 16 divided by 16, that's 1. X squared divided by x squared, that's 1. So what would be left? Y to the 4th divided by y gives me what?
Y cubed.
Y cubed. Good job. And then the last one, 32x cubed y squared.
2xy.
2xy. Good job. That leaves you guys 2 to do on your own. We'll see how you did tomorrow in class. You guys can do it. I have faith in you. Thank you for coming to Math Lab.
You're welcome.
Thank you for participating. I really appreciate everyone's help. Have a blessed afternoon.
You too.
Take care. Bye-bye.